Roots of variable expressions. Finding the nth root of a variable expression. The nth root of variable expression is similar to finding the nth root of a numerical expression. For roots with even indexes, however, particular care must be taken to obtain a non-negative result. If n is a positive odd integer, then the nth root of a to the n is just a. And that says if you got an odd index, don't have to worry, you can have negative answers, no problem. If n is a positive even integer, then the nth root of a to the n is the absolute value of a. So what you're going to be looking at is, if I take the cube root of negative 3y, the quantity cubed, it's just negative 3y. That's an odd index. What happens is, this negative 3, this 3 kills that 3. You're taking the cube root of something cubed. It's just that thing. Even index, however, if I take the cube root, the fourth root of that thing, the fourth root of that thing, that would say the 4's cancel each other out. I'm left with negative 3. I can't have a negative number if I have an even root. Well, why? Because something times itself an even number of times can't be negative. So what you have to do is you have to put absolute values around it, and it comes out to be 3. So even index, you put absolute values around. Odd index, you don't. The fourth root of minus 2x to the fourth, you notice it's just the 4's reduced, cancel each other out. They put absolute values around it. It is the absolute value of negative 2x. That's a perfectly good answer. But the absolute value of negative 2 is just 2. And so it's 2 times the absolute value of x. That's what they would do. The absolute value of 4, and then a set of parentheses to the fourth. Again, these two reduce each other out, and you've got the absolute value of the radicand, and then they simplified it. Don't worry about it, and if they have absolute values around your answers, just ignore it. But that's where it comes from. It's a fact. The problem tends to be, and let me